right, so if we have a look at example 1, smidgen bigger so that we can all see. We have got a triangle here, and we're going to do a whole bunch of fun things. So in the figure, ED is parallel to BC, and EC is parallel to FD. AD over DC is equal to 5 over 4, AF is equal to 3x minus 5, and FE is equal to 2x units. So much information. And really, before I can even begin to answer the question, I need to actually understand what all of this information is saying to me. So the parallel lines hopefully are not too tricky. They're just telling us the parallel lines. So ED, BC, I'm going to highlight in green here. Now, guys, the reason I am highlighting these parallel lines is because they're going to help us a bit later on if we need to prove proportionality or similarity. Mostly proportion, because remember, proportion relies on parallel lines, but it's just useful to know what's happening. And then FD and EC in blue here. Not very well though. Right, the other reason why I want to highlight them is because hopefully what you can see is that depending on which parallel lines you work with, there's two different triangles that we could be working with here. So if we're working with the green parallel lines, we are then working within, as a proportion theorem, triangle ABC. So the green triangle over here. But if, however, we're going to now work with the blue parallel lines, we are now working in triangle ABC. The blue triangle that's really not very well drawn. And actually it's just embarrassing. And it just got worse. I'm like a toddler. Can't draw a straight line for anything. Okay, there we go. So I've got a blue triangle, I've got a green triangle. I just need to be mindful of that. And this is, I think, we struggle with these questions. The second we start adding multiple parallel lines and multiple triangles we need to be working within. Okay, that's just the parallel lines. Understanding the parallel lines, understanding that it breaks the shape up into two different proportionality theorem triangles that I could use. Then we get to the next bit. The next bit is that AD over DC is equal to 5 over 4. Now remember, I said to you before that a fraction is basically the same thing as a ratio. Fractions and ratios tell us exactly the same information. One's just written as a fraction, one's just written as a ratio. So this as a ratio is telling me that AD to DC is 5 parts to 4 parts. Now that's helpful to me. Here's AD. So there's 5 parts. If you want to use a variable, you're obviously welcome to. And here's DC. Horrible bracket, but you get the drift. 4 parts. That is exactly what that ratio told. Then the next bit of information, which is a lot easier to grapple with, is just lengths. So AF is 3x minus 5. So here's AF. FE is just 2x. Now, obviously, guys, bear in mind that that means that you know the length of AE. If you added those two together, it would be 5x minus 5. I don't like that it's there, but anywho, you get what I'm saying. So just bear that in mind. Bear in mind that as you start to figure things out, as you start to apply information to your diagram or in your questions, you're actually potentially able to get a bit more out of it than you initially thought. Right, so that's just all the information. We haven't even looked at what the question is asking me to do yet. So let's do that now. This question is asking me to calculate the length of EB. So if we look at where EB is this tiny little segment down at the bottom there. It's just a segment of a triangle. It's not the entire length in a triangle. It's just a tiny little part of the whole big green triangle side AB. Now, Gretel, there's lots of different ways that you can do this. You have to decide what works best for you. In my opinion, if you can set up a ratio automatically with what you want or what you're trying to look for, so in this case, EB, you can then figure stuff out from there. So that is always my advice to my kids, and is my advice to you. Set up a ratio that involves EB, or set up a proportion, expression, equation that involves EB. So to do that, EB, that's what I want. And remember I said to you, when we did proportion, always put the side that you want in your numerator. There it is, EB. Now, if I look along that side, that whole side AB, I now need to figure out which makes the most sense for me to go and write as this ratio, as this proportion. I've already done EB. So either I could go and write AE, I could write the whole side length AB. I need to decide which makes the most sense. Now, remember I said to you, because you know what AF and FE are, you know that the whole side length of AE is 5x minus 5. And because you know that, I'm going to use that. I know that bit of information. So AB over AE is equal to, just erasing things there, front and center here. EB matches up in my green triangle with DC over, and AE matches up in my green triangle with AD. So I've set up a ratio. Granted, I'm not entirely sure if I know all the information for this ratio, but I can get it. Okay, I can work stuff out. Remember your reason. So this is prop theorem. And if I want to spell prop. And we have to state the parallel lines, and those parallel lines in this case are ED parallel to BC, the green triangle. Now that I've got the ratio containing what I want, I'm going to start filling in some information. So I'm going to fill in the stuff that I know. Sorry. EB I obviously don't know, that's what I'm looking for. But AE I know. AE we know is that 5x minus 5. We worked that out earlier. DC, now remember DC, I know what it is as a ratio. DC to AD, if you look back up here, is 5 over 4. That's awesome. Now I'm starting to get somewhere. I'm starting to figure out stuff that I initially didn't know, but I can now substitute in. Now, if you want to, you don't have to go this step far. We could isolate EB and say that EB would be equal to 4 times 5x minus 5 over 5. Just so that we're all clear where that came from. I'm multiplying. Oh, that's a little aggressive. What I'm doing is I'm multiplying by the 5x minus 5 to get EB alone. But remember, they need to do that on the right-hand side as well. So that's what creates that fraction. And the reason I like this method of setting up my ratio as my first point of call is because now I can see that the only thing I don't have is x. So x is the only bit of information that I need to find. Again, it's very aggressive. Let's try again. And now I can go and say, okay, cool. I've got everything I need. I know where I need to go. I know what I need to find EB. Now I just need to work out the value of x. Now remember, great tools, every bit of information we give you is important. If you look at what I've used thus far, I have been working in the green triangle. So I've been using the parallel lines ED and BC. I have yet to even touch that blue triangle. Now this makes sense that I'm going to use it in my next step. The reason this makes sense is because, remember, you know the ratio of AD to DC, 5 parts to 4 parts. You know that AF is 3x minus 5 and FE is 2x. And if you go now look in your blue triangle and you match those up, AF matches up with AD and FE matches up with DC. I can state up another proportion. So that's exactly what I'm going to do. You can start with whatever you want. It really makes no difference. AF over FE is equal to, remember, AF matched up with AD and FE matched up with DC. Prop theorem. But now I'm in the blue triangle, FD parallel to EC. Now I sub in what I know. So I'm using exactly the same method as what I'm using to set up that first proportion. AF is, okay, we're going to have to go a line down apparently. 3x minus 5. FE is 2x. AD is 5 parts. DC is 4 parts. Great. I have got an equation I can now go and solve. Obviously, you're welcome to find an LCD if you want, but remember the trick is just to cross multiply to get rid of your fraction when you've got one fraction on either side. Oops. So this is going to be 4 times the 3x minus 5 is equal to 5 times 2x. Simplify is 12x minus 20 is equal to 10x. And now we can obviously solve for x. Bring the 10x over, 2x is equal to 20, x is equal to 10. So now I know what x is. I can now take that and substitute it into that equation that I was working with. Because remember we said the only thing we're missing is that x value. Now that I've got it, I can go and just sub in. So now I know that EB is equal to 4 times 5 times 10 minus 5. Obviously, you can simplify all of this if you want, but I would just substitute it in and chuck it into my calculator. And so that tells me that EB is equal to 36 units. Obviously, I don't know the specific unit of measurement. I wasn't given that information, but I can work out what it is just as a unit. So guys, when you get questions like this that are a little scary because of how much information there is, don't overthink it. Start, as I already explained, by setting up a ratio that contains the length, the segment that you want. So I started right at the beginning by setting up a ratio that contained EB. It does not matter if you don't know everything. So if that ratio has bits of information that you do not know, that is fine. You will go and work it out. So in this one, I didn't know what x was. I didn't care. I could go and work it out. When you get diagrams like this where there's two sets of parallel lines, one of them is going to help you set up the ratio for the actual answer you want. So the green triangle here. The other set of parallel lines is going to help you find the missing information, the blue triangle here. So don't panic if once you set up a ratio, you've got missing information. That's fine. You have got enough in your diagram, you've got enough in your information to figure out what you need to figure out. So, excuse me, just because I didn't know what x was initially, doesn't mean that I've done something wrong. It just means I need to go and work it out. Now, some people do prefer to work that information out first and then go and set up the ratio. So some people like to do what we did in blue, solve for x, before they do what we did in that pinky purpley color, find EB. That's obviously absolutely fine. The more you do these questions, the more you're going to see is if you have an x value, you're going to have to at some point work out what x is. So if you want to start with that, start with that. There's nothing wrong with that. I just prefer to set up my equation or my ratio or my proportion because then it leads me to where I need to go. That pink bit of information led me. I now need to find what x is. So I knew what my next step needed to be. And I think that's sometimes where geometry is a bit confusing. We don't always know what our next step is. But in this case, because of setting up my initial, this is what EB is equal to, it pushed me, it guided me to say, okay, cool. Now you must go find x in order to find what you want. So it just helps guide us along the right direction. Okay. If you've got questions, obviously, guys, just remember to ask. Just slipping and sliding all over the place. But let's take a screenshot and then let's have a look at our next example. Okay, so I'm actually going to ask you guys to try this example by yourselves because it's very, very similar to what we've just done. So hopefully you've got your screenshots, you can refer back to it. So here's example 2. You're going to try it by yourselves, but I'll read through the information with you, obviously. So in triangle QRS, which is the big triangle that we have here, T and U, are points on RS, and W is a point on QS, such that QT is parallel to WU and QR parallel to WT. If QW is equal to 12 millimeters, WF 11 millimeters, and TU 6 millimeters, find the length of RS correct to the nearest whole number. Okay, so if we just break down what we have there, again, you're going to try it by yourself, but let's just make sure we all know exactly what information we have. Let's see. We don't know. No, let's try that sentence again. We don't have on the diagram where the parallel lines are. Sometimes they do this. Sometimes we tell you in the information of the question a bit of information, but don't put on the diagram. So QT parallel to WU are the blue lines over here. Obviously, if you want to, if you're drawing this diagram for yourself, if you want to go and put the little arrows on to show that they're parallel, that's obviously absolutely fine. And then the next set of parallel lines we were given was QR and WT. So QR in pink. Oy, oy, oy. QR. How are you finding? Technology. I can't. Okay, cool. Whatever. QR, WT. Again, if you want to put the little arrows on your parallel lines, go for it. Nothing wrong with that. Apparently, I can't even do that. So, whatever. Okay. Then we were told some length. QW is 12 millimeters. WS was 11 millimeters. Now, just remember that means that technically speaking, you know the whole length SQ, because if you've got 11 and if you've got 12, you just add them together to get SQ, so 23 millimeters. And TU, so the segment over here, is 6 millimeters. That's all the information that you have. So I'm asking you to find what SR is or RS is. Now, if you have a look, currently we're just doing absolute nonsense right now. Sorry, I don't even know how that happened. If we look at where RS is the entire side length of the big triangle QRS. Right, so give it a try. Let's see what we come up with. I'm going to give you like 5 minutes and then we'll see where we're at. If you guys have questions while you're going, obviously, please feel free to ask. Okay, guys, and just remember the question says to the nearest whole number. So when you have your answer, make sure you round it off correctly. Because the question specified that, there will be a mark allocated for it. So just make sure. Okay, guys, I'll give you another minute or two and then we'll have a look. Okay, let's have a see. If you're not done, again, don't stress, just mark along with me. Let's see what we need to do here. So again, lots of different ways to do this. You decide what works best for you. For me, it's going to be setting up a ratio that already involves RS. Now, guys, as I said before, put it in the numerator. I don't know what that was. Right, so RS over. Now we need to decide what it makes the most sense to be over. Look at the information that you have. So RS is the entire side length, which means I need to be looking at my pink triangle. Now the pink triangle, you know what, or you can eventually get a ratio for TR because of the 12, and you can get a ratio for ST because of the 11 millimeters, so it doesn't really matter. I'm going to go ST just because I've got the 6 millimeters there already, got part of the line segment. I'm going to go ST. So RS over ST is equal to, now match it up in your, or using the pink parallel lines. RS, the whole side length, matches up with the whole side length SQ, and ST matches up with SW. Prop theorem, parallel lines with the WT, the pink, and the QR. Cool. Now I'm going to substitute in the information that I know. RS, obviously, I don't know. That's what I'm looking for. ST, I don't know. But remember, I said it's absolutely fine if there's stuff we don't know, we can work it out. SQ, I know because it's the whole side length 23. Okay. And SW, I know because I was given that as 11. So I'm already starting to gain some information here. Now remember, I want RS. So if you want to go and isolate this for yourself, that's fine. We were times by ST on both sides. So 23 ST over 11 will give me the length of RS. That's great. Now I actually have something I can work with. If I go and have a look at this information that I've just found for myself, what I see is that the bit of information that I need is ST. So I now need to go and figure out what ST is. And this is now where the blue parallel lines come in. I've used the pink parallel lines. I'm now going to use the blue ones. So this is now in triangle SQT. So that green triangle I've just traced there. And I want ST. So set up your ratio. ST over. I know UT. So let's do it over UT. Is equal to ST, the whole length matches up with SQ. And UT matches up with WQ. Again, this is because of prop theorem. But now I'm using UW parallel to QT, those blue parallel lines. sub in what we know. ST is obviously what we want over UT, which is 6, is equal to SQ, which is 23, over WQ, which is 12. So that means ST is equal to 23 over 12 times 6. We're looking at the situation there, but anyway. So ST is equal to 11.5 millimeters. Great. Now I know what ST is equal to. I can substitute it back into that equation. So RS is equal to 23 times 11.5 all over 11, which gives me 24,04. It's a whole long situation. But the question said to the nearest whole number, so this is approximately 24 millimeters in length for RS. So that weird little squiggle there with the line underneath, this means approximately, just in case you've never seen it before. And you're more than welcome to use that when you are rounding with a value. Okay, guys, so this one, like I said, pretty much the same as the first question we had a look at. If you set up the ratio in terms of what you want, oh gosh, looking more disheveled by the second. If you set up the ratio in terms of what you want, so that ratio for RS, you can figure out what you still need. You can figure out what you need to go and work out. We saw that we needed to work out ST still, so we went and did that using the other triangle that I hadn't yet used, or the other pair of parallel lines I hadn't yet used, and then I could go and substitute that. Now, guys, this is again why I like this method. So in the first question, we could clearly see X was going to be needed. And so that's why I said to you, if you started by working out X, fine, awesome. But in this question, immediately just looking at the information, I can tell you right now that there is no way I would have thought, cool, I'm going to have to work out ST at some point. In a test, in an exam, when you're already feeling anxious and stressed, there is no way, unless you are really, really good at this, which I'm then really jealous of you and you're very lucky. There is no way that you can look at this and say, okay, cool, based on everything I need, I'm going to have to work out ST first. This is why I like the method that I have where you set up your ratio of what you want first. Because then you can go, and again, you're guided to what you need to go and figure out. There is no chance on this planet that I would immediately know to work out ST there. I only knew I needed ST because I set up my ratio for RS. That's the only way I knew it. Otherwise, I would have been plodding along, confused as all hell. So this is why it's really useful to set up your ratio first so you can figure out what you need. Otherwise, you just go around in circles trying to figure out stuff that is actually irrelevant or is just way too complex. So this is why I like this method. Again, you do you. Whatever works for you. This is what I'm advocating for. This is what works for me and what I think works for people, works for students who maybe aren't as super comfortable with geometry. Okay, I'm not always, geometry is not always my favorite situation. All right, so see how you go. Okay, there was a question of would I be wrong because there's a difference in my answer? So just be careful. The question did say round to the nearest whole number, but that was only in relation to RS. So every other bit of information that we have, we should keep as a non-rounded value, and we should only round off our final answer. So I would leave 11.5. I would only round off to the nearest whole number in my final answer. So only in any case, you should never be rounding off until your final answer. I hope that answers your question. If not, just shout. But yeah, basically rounding, never round off until your final answer. You have the answer button on your calculator, so it's not like you need to type out a whole long decimal. You just use the answer button. So it isn't super problematic. Alrighty. Let's have a look at the next one. So example 3, we're now getting to similarity. I know that because the first question asked me to prove similarity. I can't remember, and someone can correct me. Did I say do this one last week and we would check it on Monday? You can correct me if I'm wrong. I might have just dreamt this whole scenario up. Does anyone remember? Like I say, if I'm talking nonsense, just let me know. I'm gonna go. The silence is telling me that I'm talking nonsense, and I probably dreamt the situation up. So we're just gonna move on swiftly from that. Pretend it never happened. Cool. In the diagram, EF is parallel to CGD. Now, guys, just because there's three letters there, it doesn't mean anything weird. It just means that there's 3 points along that line. Remember, you can have a number of points along a line. It doesn't really matter. So EF parallel to CGD. That's the green lines that I'm highlighting. And here's the multiple points along the line, C to G to D. Doesn't matter. Still a straight line. Still parallel to. And BEC, so same situation over there, is parallel to FC. So these are going to be the slanted. I do apologize, that took me by surprise. So the slanted pink parallel lines, BEC and FG. Cool. So we've been given some parallel lines, and we have been asked immediately to prove that some triangles are similar. So given the fact that we just did this on Wednesday, I want you guys to go and answer the first question for me, which is asking you to prove that triangle BEF is similar to FGD. So BEF is this triangle up here. FGD is this triangle down here. I want you to prove that they are similar for me. So remember, similarity, there's two ways to prove it, either showing that all corresponding sides are in proportion or through angle, angle, angle. In this case, you know nothing about the sides. Absolutely diddly squat. You can't show that the sides are in proportion. So you're going to have to use angle, angle, angle. It's the one we actually use the most. I'm not saying that we can't use sides in proportion, but it is the one we use the most. Right, so 3 minutes. 3 minutes for 3 statements. Let's prove that those two triangles are similar. Okay, guys, let's have a look-see. If you're not done, again, don't stress. You just mark as we go along. So we're just wanting to prove similarity here to start off with. Now, you'll see in the next question, hopefully we get there. I don't always have to ask you to prove similarity, but you might need it in order to answer a question. In this case, I've been nice. I have led you and said, or scaffolded and said, cool, you're going to need similarity. Right, so in question A, we're looking in triangles BEF and triangle FGD. So those yellow triangles I've got there, and I need 3 segments. Remember, I need 3 angles. Okay, now what we need to be careful of is that there's no overlap of the triangles. So that means we can't have any like common angles, common sides if we were looking at congruency. There's no overlap. But we do have parallel lines. So if you look at your pink parallel lines, we can see that angle B corresponds with angle F3. So angle B is equal to F3 corresponding angles. And then remember, you have to state your parallel lines. So BC parallel to FG. So that's the first set of angles we know are equal. The next set of angles that we know are equal are F1 and D. Again, these are corresponding angles because of the green parallel lines. So angle F1 is equal to angle D, again corresponding, and EF parallel to CD. And then guys, remember I said this to you before, if 2 of your 3 angles are the same, the third has to be. So E1 is equal to G2, I'll put a 1 there, sum of angles in triangle. Now what I want to point out that I haven't before, and that's completely on me, is if we just take the yellow highlighter and so we were proving that the purple triangle is similar to the yellow triangle. If you have a look at how I set up my similarity working out, angle B, angle F1, and angle E1 were all the first angles that I worked with. And if you set it up like this, that you keep all the angles from the same triangle as your first position or your second, vice versa, it does just make your life a little bit easier, especially when you're trying to check whether or not you've got the correct order. So what we can now go and do is when we set up our order, we can see that we've got our angles all lined up from each triangle. So now when I want to say, therefore, triangle BEF is similar to triangle and double check the order, I've already done that. So angle B corresponded with angle F, F3, but we just use the letter. Angle E in the purple triangle corresponded with angle G. And angle F in the purple triangle corresponded with angle D in the yellow. And so that's how I can check that my order is correct. Okay, it seems like a really silly thing, but it does just help if you keep your triangles sort of lined up on each side. So we have proven similarity, which means we can now go and have a look at that ratio question in B. Okay, so question B, I am wanting to prove DG over FG is equal to EF over BE. Now remember, we said this last week. Don't even look at that just yet. Set up your ratios. So what I mean by that is BE corresponds with FG. So BE over FG would be equal to EF corresponds with GD, which would be equal to your first and your last now. So BF and FD. And we know all of that is true because we've proven similarity, and so we know that these are corresponding sides that are in proportion. My mind just blanked it. So corresponding sides in proportion. Now that we have that, we can go and double check what we want. So yes, we saw it was a ratio question. Cool. Let's first sort out what we need to sort out. So if we go and have a look at what we want, we need DG. I don't know, I'm confusing myself here for some silly reason. We need DG FG, EF, and BE. So here's DG, here's FG, there's EF, there's BE. So we are going to work with the first two fractions in the ratio I've just set up for myself. That's going to allow me to answer this question. So I know that BE over FG is equal to EF over GD. Now, just remember what it is that we want. And the reason I'm pointing this out is because this is slightly more complex than what we used to. So DG over FG is equal to EF over BE. This is what we want in this red block over here. So we just need to be careful. Essentially what I want to do is I want to take the GD. Okay, cool. Let's try that again. I want to take the GD and I need to move it up to the numerator. And I want to take the EA, the BE, and I want to move it down to the denominator. That was just, boy, a toddler could do better than what I'm doing here. So let's take all these scribbles off and let's try again. As the grown-up I am. GD needs to go up to that numerator. BE needs to go down to that denominator. Now it is just a simple switch, and you're welcome to just do a simple switch. There's nothing wrong with that. There is mathematical reasoning why you would do that. Obviously, to get GD out of the denominator, you would have to times both sides by GD. And to get BE out of the numerator and into the denominator, we'd have to divide both sides by BE. I don't need to see all of that. Essentially, you are more than welcome to essentially flip those two things around, which obviously would help if I did, and say DG over FG is equal to EF over BE. That is absolutely fine. I don't need to see your manipulation of it. Obviously, you're welcome to show it if you want, and I've explained how you would do it, but it's up to you. So you would have to multiply by GD or DG, and you have to divide by BE in order to end up with that ratio that you wanted. Okay, but the thing that we're sort of checking for, the thing that we want to see here is the setup of your ratios and your understanding of the sides being in proportion, and then understanding that you can then make that statement. If you want to show the manipulation, fine. It's not something you have to do. Okay, let's just touch smaller. All right, guys, so take a screenshot. I really hoped we would have time for the next one, but I don't think we're going to. Just sad, but we will just include it next week. It's not the end of the world. Practice week's perfect. Okay. Right, have we got those screenshots? Let's see how much we can do. What if we don't finish? We'll carry on Wednesday. Right, and the reason I'm saying I'd really like to do this one is because this is now incorporating circles. And as I said right at the start of the lesson, often what's going to happen is within your circle theorems, you're going to have proportionality and I mean, said it's simplification and similarity. Okay, so circles ABC. Now, when we talk about a circle ABC or PQR or whatever, all we're saying is that it passes through those points. So circle ABC passes through the points A, B, and C. So that's the larger circle on the left. And ABD, smaller circle on the right, intersect at A and B respectively. AC is a tangent to the circle ABD. So here's AC. It is a tangent to the small blue circle over here. Not my best circle drawing, but you know, we pretend it's fine. And then in the same vein, AD, so this green line, is a tangent to the circle ABC, so the circle that I'm going over in green there. So I've got tangents to circles. Before I even carry on, the second you see the word tangent and circles, you should be thinking tan-chord theorem and tan-per-Brad. Now, tan-per-Brad not really here because of the fact that you have no idea where the center of these circles are, so you don't know where the radii are. But tan-per-Brad, you should automatically be thinking about. And this is going to be really important because in the first question, it's asking you to prove that a ratio is equal. we know that we can only prove a ratio is equal if we know that the triangles that those sides exist in are similar to each other. So if we go and have a look, we've got BC, AC, AB, and AD in that ratio. What I would do is I would just go and find those sides. Because right now, you're not I mean, there's only 2 triangles here, so it is fairly obvious. But sometimes it's not obvious which triangles that you're working in. And so if you go and highlight your sides, so there's BC, then we want AC, which came in arrows. There's AC. So there's B. BC, whatever. Then we were asked for AB, which is the side down the middle here, and then we were asked for AD. So if you go and have a look at all of that information, it's very clear we're going to be looking at these 2 triangles here. And in those 2 triangles, if we can prove that they're similar, we can then go and use that ratio. So, excuse me, it's really important that when you are given information like this, you are looking at everything as a whole. The fact that those 2 triangles are the chords created with tangents and then chords in a circle, again, tan chord theorem should be alarm bells ringing. The other thing that I know is because I was asked to prove a ratio equal, I can only do that with similar triangles. So what you would need to do here is you need to prove these triangles similar, and then you would be able to go and answer question A and B. Right, so I really got as far as explaining the question. I'm going to let you take a screenshot of this. Give it a try. See if you can do it before Wednesday. Otherwise, we'll start Wednesday's lesson with this question and go through it before we look at the others I have prepared. But try, because this is a typical type of question where I expect you to understand that if I'm asking for a ratio to be proven equal, I expect you to know that you need to use similarity. So even though nowhere in that question does it say prove triangle ABC similar to triangle ABB, you have to do it. You can't do this question without the similarity proof.